Now I know that the lathe doesn't look like a car, but don't let that fool you. It needs some automotive TLC, or at least automotive adjacent. Alright, so I've just been down to my local Super Cheap Auto, and I've just picked up an SCA Classic, a $5 oil filter from the discount bin. And what I'm going to try and do is connect it to the lathe, somehow. Now as I'm sure some of you have noticed, the lathe, it sounds a little bit crunchy these days. Really, not what a lathe should sound like. I mean, it's not bad at high RPM, but when I drop it below 500, it doesn't sound all that great. Now of course there is a limit to how good a spur gear driven gearbox can sound. Out of all the type of gearboxes you can go for, these are easily the loudest, but this lathe is really wanting some new bearings. But before I drop $150 and spend several days tearing it apart and then rebuilding it, I do want to do something about the oil filtering. In that I need to add one, because as it is at the moment, it doesn't have any. Now that probably shouldn't be too much of a surprise, because this was not an expensive lathe. In fact, it was the cheapest one that I could get with a proper 13-speed gearbox, which is actually quite impressive for a machine of its size, but the gearbox is still quite basic. All it really is just a cast iron box with gears, shafts and bearings. So any particles caused from wear from the gears rubbing, and these gears aren't hardened, so there's a fair bit more coming off them than you would expect. But that all ends up in the oil, and I don't know how well you can see it, but it does not look very good. And the problem is that oil constantly gets recirculated into the gearbox and more importantly, into the bearings, which can't be good for them. And every time that I do change the oil, it always comes out looking pretty rough. I'm sure if the gears were surface level hardened, like you would get in a differential, it would be a bit of a different story, but that is asking a lot from a lathe like this at this price point. Now I have had a few people say that chucking a magnet in at the bottom of the gearbox will help to attract and reduce the amount of particles in the oil, but as you can see it doesn't do a whole lot, and cleaning them is quite difficult. So the way that I see it is that a proper oil filter should be able to do a much better job, keep the oil clean and hopefully increase the life of the bearings. And this is where the pump that I previously made will come into the equation. If you didn't see that video, all this really is just a basic external gear pump. It uses two spur gears in a housing to pump fluid. In this case, it's going to be gearbox oil. Now the reason why I made it such the way that I did was so that I'll be able to mount it in the back cabinet on the back side of the lathe. It fits in there really nicely, and what I'm planning on doing is making some sort of belt and pulley and then using the spindle motor as a way to drive the pump. So that means when I turn on the lathe and it's spinning the spindle, it's also going to be circulating oil from the gearbox to a filter and then sending clean oil back into the gearbox. Now of course if you really wanted to, you could wire in a pump with a separate motor to turn on when the lathe turns on, but I really like this design, this sort of single driven setup, which is why I'm going to do it this way. And it's a 1 horsepower motor and it takes no effort whatsoever to drive the pump, so we really shouldn't be seeing any drop in performance at the spindle. Now of course the most logical place to put the filter would be on the back of the housing like so. There's obviously enough room for it and the housing is wide enough, so there's no problem there. But because it's increasingly likely that the pump is going to be mounted right behind it, inside the housing, means that it's going to be a lot easier for me if I mount it vertically with some sort of bracket holding it on. Doing it this way means that the barbs and the fittings won't be sticking into the housing. Now as for the material, I don't really have quite what I would really like to be using in this situation. I mean it is big enough, but I'd really be wanting something a little bit thicker than 20mm. But like always, I'll figure out a way to work with it. And I'm pretty sure this stuff is 6061 aluminium, which is perfectly fine to use, although it's not the nicest stuff to machine, but I can definitely work with it. And as you can probably see, it's a leftover piece from a part that I've obviously abandoned in an old project. I've obviously started to cut and then chosen halfway through to use another piece of stock. The good news is that it'll work just fine as our starting piece. I've also got a small offcut of aluminium which I'll use as the bracket. So with all that said, let's jump in and get it started. So the first thing that I want to do is get a round disc cut out from this, and it's probably easiest if I do this on the lathe. And I think the easiest way to hold it on the lathe would be to use an arbor. So the first thing that I'll do is I'll take it to the mill and use the boring head to bore a hole. Alright, so now we can get it in the lathe. Alright, and that's held on pretty tightly. Now instead of coming in with a lathe tool and dealing with an interrupted cut, I think it's going to be a lot faster if I come in with a hole saw and then cut it out that way. I've done this quite a few times and it works surprisingly well. Now the hole saw isn't deep enough, so I am going to have to flip it. Alright, and that worked out pretty nicely. Now we're still a bit oversized, so I'll come in and take it down to match the same size as the oil filter. I can now get it chucked in the 3-jaw and then face off the end. What I'll do now is I'll come in with a boring bar to create a sort of recessed area on the front face. Now the purpose of this space is going to be for our oil inlet. If you weren't already aware of it, the way that these screw-on oil filters work is that the oil comes in through the outside inlet holes, through the filter mesh, and then out through the center hole. So what that means is we need a space between the oil filter and the housing for the oil to fill. The diameter just needs to be a little bit smaller than the gasket on the filter housing. Alright, and that is the lathe work now done for this piece. Although it's not done yet, it still has quite a large hole going all the way through it, and it does need threads for the oil filter. Now in a perfect world, I'd make a mount like this from a solid piece of aluminium. It would be long enough to have the threads machined into it, which would have been nice, but obviously I didn't have a piece that was thick enough. With that said though, I think the most common way to do this would be to have the threads as a separate piece and then have it screw in. And that's a really good choice if you want to offer several different thread types, but there's always a risk of it unthreading unless you have a way to lock it in. Plus I need thread adapters on both sides and this piece isn't very thick, so there really wouldn't be a whole lot of engagement. So instead what I'll do is go with option 3, and that's to press fit in a piece of aluminium with the threads already cut into it. Now a good press fit should be oil tight and it should hold up under a bit of pressure, but it needs to be a good press fit. So what I'm going to go for is about 50 microns of crush between the two parts, so it needs to be made very accurately. Alright, and that should be pretty much spot on. Now at this point I can now start to cut the threads, and with oil filters there are a lot of different oil filter thread types you could go for. A lot of them are Imperial, but the one that I picked up I made sure was an M20 by 1.5, which the lathe is capable of doing. Now what I want is a good fit between the threads, so what I'll do is I'll start to machine it till it's close, and then I'll start test fitting it, taking off a little bit in between until I get a perfect fit. And that is about as good of a fit as you could ask for. I'll then drill all the way through to create an oil channel, and then I'll get it parted off. Alright, and that's the two parts now made. I could probably press it in right now, but what I'll do is I'll go and chuck it in the freezer to help it shrink a little bit and help it go in. Alright, and that went in there pretty nicely, and if everything went well, it should be in there for good, and it should be oil tight. We'll have to wait and see, but I'm pretty sure it should be good. With that said though, it's still not done yet. It still needs an inlet hole and 2 holes for the mounting bracket. So I'll take it to the mill and then get those drilled and tapped. Alright, and that came out looking pretty good. As you can now see, there's an inlet hole, and it should allow oil to get into the oil filter. And given that I'm not expecting a high flow rate, one inlet on one side of the oil filter should be more than good enough. Alright, so the filter screws on really nicely, and as you can probably see, we're getting a nice faint line from where we were getting really good contact with the gasket. All in all, good stuff. So with the main part now done, let's go ahead and make the bracket. Okay, so I've gone ahead and sketched out a rough idea of what I want, and the only thing that's getting in the way is that tap hole there. It goes in maybe a third of the way through, and it's one thing that I will have to work around. So the first thing I'll do is go in and clean up the ends. And to do that, I'm going to go and use a roughing end mill. I know it's usually bad luck to use a 4-fluted end mill on aluminium, but these roughing cutters are a totally different beast. The little serrations on the flutes leave a pretty rough finish, but they turn the aluminium into these tiny little grains, and there is no way that it could clog up an end mill. And more importantly, it does a much faster job than a standard 2-flute end mill. Honestly, these roughers do an amazing job, and if you haven't tried them on aluminium yet, I encourage you to try them. Although you will need to come in afterwards and clean up the cut. With it now cleaned up, the first thing that I want to do is come in and make a semicircle on the end to interface with the oil filter. In the past, I probably would have done this with a boring head, but I think I can do this in about 1/10 the time if I use an annular cutter. Now, I've never used an annular cutter on a cut like this, where you only get half engagement, but it's doing a fantastic job. And like it normally does, it left an amazing finish. Now, the rest of the bracket is pretty straightforward. It's essentially a right angle with a rib down the center to give it a bit of extra stiffness. Although let's be real, it's total overkill, but I think it'll make the design look a bit nicer. So I'll come in with the 2 flute end mill and create the basic shape. Alright, and I think that's come out looking real nice. Although I haven't been able to completely remove all traces of that tapped hole. Although no problem there, I'll simply come in with the cutter and mill in a slope. Alright, well that could have been pretty bad. I just caught it right before the cutter started to cut away at that front edge. Always got to pay real good attention when you're machining. Thankfully I can switch out the cutter and continue without much trouble. And I think that turned out looking pretty good. All it needs now is 2 more holes and it is done. Alright, and that is the second piece now done. Nothing left to do but go ahead and get it assembled. Alright, and that is it all now assembled, and honestly, it doesn't look too shabby if I say so myself. Honestly, it's a real shame that it's going to be hidden behind the lathe. Although in fairness, if it was intended for a car, it would be hidden under the bonnet. With that said though, it still needs a barb for the inlet and the outlet. Yeah, and that is now certainly looking the part. Now I'm not going to mount it just yet because I want to get everything else done first, but I think it is important that I go ahead and test it just to make sure that it works and it doesn't leak. But before I do that, just a quick follow up on the pump which I previously made. Now I'm sure some of you will have noticed that this, unlike the name suggested, is not a situation where you would call it a hydraulic pump. I guess it will be under a bit of pressure, but it's really not hydraulics. Now technically, this pump here is not going to be used for hydraulics, but what this pump is a test bed to see if it actually works. And if it works good enough, pump number 2 is going to be used in a proper hydraulic system. And I would have had pump number 2 here if I didn't have to rebuild that whole bottom section and use up all my aluminium. But I still would have done this project first because I need to see if it actually works. More importantly though, we do need to address the gasket. You see, the pump was designed to work with these thinner paper gaskets, and when it didn't work and I switched over to the 0.4mm one, I inadvertently added about 0.8mm of extra height, which may not seem like a lot, but that is a lot of extra space for the oil to leak, which will massively reduce the efficiency. Thankfully though, it's not a huge worry, because I've gone back to the original gasket thickness, but I've used a different paper stock, and I've made a much nicer gasket, and it should do a much better job. And in testing it, it certainly made a positive impact. It's still pretty rubbish at self-priming, but the flow is a lot better, and it is a lot more consistent. And of course, most importantly, there was no leaks whatsoever from the pump. So with all that now sorted, let's test the pump with a bit of pressure, with the filter now attached. So the way that I've set this up is that the oil goes from the bottle to the pump, it will then go to the filter, and then from the filter it will go back into the bottle. Essentially one big loop. So let's go ahead and see if it works. It's going to need a bit of time for it to fill up the oil filter before we see anything coming out the outlet. The oil that you can currently see in the tubing was already there. In total, it took about 45 seconds for the oil to start coming through the other side, and let me tell you, that was a long 45 seconds, because if it didn't work, I'm not exactly sure what I could have done to make it work. But it comes out, and it comes out at a half decent flow rate, given the size of the motor and the speed that I'm running it. And speaking of flow rate, I'm sure it could be increased a little bit, but as I mentioned last week, flow rate here really isn't much of an issue, just as long as it's able to push out the oil, which is really all that matters here. Because really, the gearbox doesn't have that much oil, and I tend to run it for quite a long time, so it's all going to get run through. The only slight problem here is that one of the barbs is starting to leak, although it's nothing that a bit of tape won't fix. The other important thing here is that the press fit cylinder isn't leaking. If it was, it wasn't the end of the world because I could fix it, but thankfully I won't have to. And with such a tight press fit, I would have been really shocked if it managed to leak. Alright, so now with the pump and the filter now done, all I need to do now is go ahead and get it installed on the lathe. And once I've done that, I can start the process of getting it torn apart and the bearings changed. So I guess stick around for that. And with that, thank you very much for watching, I hope you enjoyed this video, and I'll see you next week.